Welcome all of you. Today in this session we are going to deal with the second module, that is solar thermal energy collectors. So before starting the actual syllabus, let's have a brief view on the syllabus of this module. Mainly there are types of solar collectors, that is what are mainly solar collectors and what are the different types of solar collectors, the configuration of certain practical solar thermal collectors, material aspects of solar collectors, concentrating collectors, parabolic dish Stirling engine system. That is mainly we have to concentrate on solar collectors concepts here, and followed by what are the mean by parabolic dish Stirling engine system, working of this system, and solar collecting system into building services, solar water heating system, passive solar water heating system, and active solar water heating systems. Then what are the main applications of solar water heating systems? Active solar space cooling, solar air heating, solar dryers, crop drying, space cooling, solar cookers, solar pond. Here mainly these are solar space cooling. From here onwards, these are the main applications of solar systems. How we are converting the heat energy into our applications. How we are converting the solar electromagnetic radiation energy into our applications, different applications that we will have introduction view on these topics. There are different topics, that is solar space cooling, solar air heating, solar dryers, crop drying, space cooling, solar cookers, and solar ponds. Followed by in the part 2 of this module 2, we will have a look at solar cells. What are different solar cells, or what is the modifications, what are the construction details, like that. The components of solar system, what are the main components that this cells will be having, and elements of silicon solar cell materials, practical solar cell IV, characteristics of solar cells, efficiency of solar cells, photovoltaic panels. These are the very important for electrical students. These photovoltaic panels, photovoltaic constructions, this will be this is having very good future for electrical students. So have a interesting topic here, and applications of solar cell systems. This is the brief introduction syllabus of this module. Now let's see one by one. Solar collectors. First, before going to the types, first we have to look on the what is meant by solar collectors. That is, solar energy needs to be collected and then concentrated. For making use of solar energy for our best applications, we have to store it first. So solar energy need to be collected and then concentrated. Residential panels collects below 60 degrees Celsius. Whatever the solar panels that we install at the rooftops or for our home appliances, these collects the 60 degree Celsius, below the 60 degree Celsius. And in large scale systems, the temperature is about 70 to 80 degrees Celsius. That is, if we are going to collect the solar energy for our industrial applications or for large scale industries, the temperature will be varies up to 70 to 80 degrees. And actually what is meant by solar collectors, as name itself indicates, these are the special kind of heat exchangers that converts the solar radiation energy. That is, solar radiation energy means that is electromagnetic radiation. The solar energy can be we get the solar energy in the terms of electromagnetic radiation, so we need to collect it. That is, a special kind of heat exchanges, and the heat exchanges between the solar radiation energy into our actual application energy. The application energies are different. For time being, that's the internal energy of the medium. The medium may be air, liquid, whatever kind of mediums. So we need to exchange the heat that the solar radiation have and into our the medium which we useful for our applications. So the solar collectors are special kind of heat exchangers that converts the solar radiation energy into the internal energy of the medium, and these absorbs the incoming solar radiations. That is, the solar collectors, the main aim of the solar collectors is to absorb the solar radiations and convert it into heat, and this heat is transferred into fluids. That is, fluids may be air, liquid, or mixture of air, liquid, or any other chemical mediums. So whatever may be, we have to exchange that heat which the solar radiation is having, and we need to exchange that solar radiation energy into our medium. So absorbing incoming solar radiation and converts it into heat, and then transfers this heat to fluid flowing through the collector. The collectors are there, the different collectors are there. These collectors will be having fluid contents, so we need to transfer the heat content of solar radiation into our fluids. This is the main working of solar collectors. Now, what are the main applications of solar collectors? That is, wherever we can use these solar collectors are solar water heaters, solar space heating systems, industrial process heat systems, solar desalination systems, and solar thermal power generation systems. So, solar water heaters. It includes thermosiphon, integrated collector storage systems, air systems, direct circulation, and indirect water heating systems. That is, these will be having in a solar water heaters. And what is meant by solar space heating systems? These solar space heating systems includes both water and air systems. That is, the space heating, the space we may, the medium, the space provided for the solar collector contain maybe the medium as air or water. In industrial process heat systems, the industrial mainly contains both the low temperature applications and solar steam generation systems. That is a low temperature system. Low temperature systems may be air or water based systems, and solar steam generation systems. In solar steam generation systems, we use industrial process of heat systems. And in solar desalination systems, these includes both direct and indirect systems of ventilation, desalination equipment powered by solar collectors. That is, here it includes both direct methods and indirect methods. Methods means we use solar cells. In direct method, we use solar cells. If it is indirect method means conventional components powered by solar collectors. So where we use solar desalination systems. And in solar thermal power generation systems, we use both parabolic trough systems, the power tower or central receiver systems, and the parabolic dish systems. Maybe parabolic trough systems, central receiver systems, or parabolic dish systems. These are different kind of solar collectors. In that systems, we use the concept of solar thermal power generation system. That is, we use solar energy to heat the water contents and gets the molecules, and these molecules will be steams. Normally, the molecules are steams. We use that steams to generate the electric power. So that concept includes solar thermal power generation systems. And what are the different types of solar collectors? There are two kinds of solar collectors are there. One thing is flat plate collectors and another thing is concentrating collectors. So these flat plate collectors are again divided into flat air plate collectors and flat plate liquid collectors. Here the collecting medium is based upon the collecting medium. The flat plate collectors are dividing. In flat air plate collector system, air is using as a medium for collectors, and in flat plate liquid systems, flat plate liquid collectors, we use medium liquid. Some liquid will be used as a medium for collecting. So what are these things we will discuss, we'll see in details in next coming slides. And one more thing is a concentrating collectors. So again, these concentrating collectors are also divided into two types, that is stationary concentrating collectors and tracking concentrating collectors. That is, in stationary concentrating collectors, the concentrating collector medium will be stationary. That is, there is no movement of equipments or there is no mechanical movements of any kind of equipments will be there. But in tracking concentrating collectors, the mechanical equipments that we use in the collecting systems will be of movements. There will be a movement of mechanical systems, so it's called as tracking systems. So the first thing is flat plate collectors. So we can see what is meant by flat plate collectors. These kind of collectors are most common type. That is, in today's what we can say, in today's applications, wherever we use flat plate collectors, solar collectors, normally we can observe that there are flat plate collectors, and they are also referred as non-concentrating type. That is, I told that flat plate collectors and concentrating collectors. These flat plate collectors also called as non-concentrating type of collectors. In this here, they have the same area for intercepting and for absorbing solar radiations. Same area for intercepting and absorbing solar radiations. That is, these solar radiations, this is a kind of a flat plate collector. This is a picture representation of flat plate collectors. What are the different kind of parts these flat plate collectors can be having? That is, it will be having insulation, absorber material, then fluid outlet. There will be outlet for fluid inlet and fluid outlet. Then this is a glazing. What is meant by glazing, that we will discuss in the next slides. Just for time being, now you can just observe that this is there will be an inlet for fluid and outlet for fluid. A glazing will be having, and an absorber for absorbing the amount of solar radiation that applying on the that falling on the transparent materials. There will be a transparent material will be there. Through that, a solar radiation is passing through the medium, and then absorber will be there. These absorber will absorb the solar radiation. Then these absorber, after absorbing this solar radiation, this heat, the solar radiation heat is changed into our applications. So here fluid is using as a medium. So that's why it's called flat plate collectors for as a fluid content. See here, these are this representation is of some top view. These are angles. You can easily observe the absorber plates, how the absorber plate looks, then insulation things, flow tubes, header, inlet, glazing, outlet. Here the fluid is inlet here, and the fluid which flows through this tubeless will be passing through this outlet tubes, and here the header will be provided. Through that our tube-like structures will be provided. These tube-like structures are called flow tubes. Through these flow tubes, a liquid will be passing through this, and which will be absorb the solar radiation that falls on the flat plate collectors. This is a glazing, and here the absorber plates. These are the plates which absorb the solar radiation easily. These are the different kind of insulation that provided for provide a opposing medium between the glazing and tubes. That's why insulation is provided to withstand the heat exchange. There are 5 important parts that a flat plate collectors is having. What are these 5 important parts? That is, dark flat plate absorber for solar energy. I have shown you the absorber part here. Absorber plate. This is a dark, which will be for absorbing the solar energy. These flat plate absorber solar energy consists of thin absorber sheet of thermally stable materials such as aluminum, copper, steel, etc. So normally these kind of flat plate absorber, dark flat plate absorber is mainly for the purpose of absorbing the solar energy. So which will be having the characteristics of thermally stable materials. These are the aluminum, steel, copper will be having the characteristics of absorbing the thermal contents. So for that purpose, the fact that the metal is a good heat conductor. Aluminum, copper, steels are the good heat conductors. So for that purpose, a thin absorber sheet of these will be using. The next thing is transparent cover. As I already told, the transparent cover will be provided, which will be allows solar energy to pass through this, but reduces the heat loss. The main purpose of transparent material that will be provided over the glazing absorbing parts, that which allows the solar energy, which normally allows the solar energy falling on the system, but it prevents the heat losses. The main purpose of solar collectors is to transfer the heat exchange. So for that purpose, we have to save the heat, whatever the amount of heat which we get from the solar energy, solar radiations. So the transparent material will be having nature of absorb the solar radiations falling on the absorbing material, transparent material, and protects the heat exchange. And these reduces the convection and radiation losses also from the absorber plate. There will be absorber plate which is here. There will be a absorber plate, and this is a insulation plate. A transparent plate will be provided over this, which is a transparent. That's why not visible in this slide. So this will, the main purpose of this is to allows the solar energy and reduces the convection and radiation losses. Because of continuous falling of solar radiation on the system, there will be a continuous falling on the absorber plates. There will be a convection and radiation losses that can occurs in the absorber plates. So in order to save this from the absorber plate, we use transparent medium. Then heat transport fluid. Here a fluid will be passing through these tubes, and this the fluid will be after getting out from the outlet. So what is this? What are the main components of fluid? What are the main chemicals that we can use? Are air can be used as a fluid, or water or anti-freezing elements. Air, water or anti-freezing elements can be used as heat transparent fluids, and in order to remove the heat from the absorber, fluid is usually circulated through the transfer heat from absorber to an insulating tank. That is to remove heat from the absorber. The main purpose of transparent fluid, the main purpose of the fluid is to remove the heat from the absorber and circulate it through the tubing structures, tube-like structures, to transfer this heat from absorber to an insulating tank. These tubes, these inlet tubes and outlet tubes transfer the liquid, and mainly to absorb the heat content that may be observed on insulation and absorber plates. These passes the fluids to absorb the heat content, transfer the heat content from the absorber modules and insulation modules. Absorber and insulation tank. That's why use fluid as heat exchanger. The next thing is heat insulation backing or insulated casing of glass or polycarbonate cover. What are the different kinds of insulating things that we can use in our flat plate collectors? Are insulated casing of glass or polycarbonate cover. Polycarbonate cover or glass can be used as a insulating materials. As I already told, there are two kind of flat plate collectors. One thing may be fluid, or main thing, the medium which will be having the air or liquid will be used as a collecting medium, the fluid collecting medium. So based upon that, fluid plate collectors will be divided into flat plate air collectors and flat plate liquid collectors. This is the pictorial representation of flat plate air. Why plate collectors comes means because air is used as a medium here. The amount of air will be passing through this here, and it will be get exerted from here. So in between that, a solar radiation is falling on here. Glazing transparent medium is used here, and a plate will be used here. Fins are there. The insulating materials. Whatever the things we just studied in flat plate collectors are the same here, but the same things will be there. Transparent medium will be there, insulating materials will be there, and different fluids, fluid-like structures will be, tube-like will be there, insulating casing will be there. Same, everything will be same. Only thing is air is used as a transparent medium. That is, air is the transparent medium here, and the amount of air flows past the absorber by natural convection or by blower. The amount of air that we use to pass through this by natural or by forcefully using blowers. By making use of, with the help of blowers, we can blow the air from here, or we can use as a natural air also. Then less efficient than liquid type, as air does not conduct heat as easily as liquid. this is less efficient compared to liquid collectors, because the amount of heat that air does not contain, the amount of heat that conduct is poor through the air. So liquid type collectors are the most efficient. By the conclusion of this thing, we can say that flat plate liquid collectors are efficient that compared to flat plate air collectors. The next thing is flat plate liquid collectors. This is the pictorial representation of flat plate liquid collectors. Here the fluid ducts are there, through that a liquid will be flowing. Same like the other structures will be remain same, that is transparent cover, absorbing plate, insulation, casing, everything will be same. Only the difference is we use fluid to pass through this, but here we use air is to pass through this. Here in the air plate collectors, we use air as a heat transfer medium, but here in flat plate liquid collectors, we use heat transfer medium as a liquid. And then this liquid gets heated as it passes through the tubes in or adjacent to the plates. That is, as the liquid is passing through this fluid ducts, the amount of heats get heated. The amount of heat that we absorb through the solar radiations is passing through these tubes whenever the fluid is just in or out of the plates. This is the description of flat plate liquid collectors and flat plate air collectors. So one thing we need to remember here is, in flat plate air collectors, we use air as the medium, and in flat plate liquid collectors, we use liquid as the heat exchanging medium. When by comparing these two methods, we came to the conclusion that the less efficient than liquid type flat plate air collector system is the less efficient compared to flat plate liquid collector, because of the one reason, that is air does not conduct heat as easily as liquid. That's why flat plate liquid collector is the good one. Then what are the different types of concentrating collectors? So these concentrating collector uses reflectors to concentrate the sunlight. The main purpose of these collectors is that they use reflectors to concentrate the sunlight. Whatever the amount of solar radiations that falling on the glazing transparent medium, they uses reflectors to concentrate the sunlight, and these concentrating collectors reduce the size of absorber. Main thing is they reduce the absorber thing, and these concentrating collectors can also reduce the heat losses, whatever the amount of heat. The main aim in solar collectors is to protect and making use of heat efficiently. The solar collectors aim is to exchange the heat from solar energy, solar radiation to our different applications. So for that purpose, we have to making use of these heat very efficiently. But so in order to reduce the heat losses, we use different concentrating collectors and increases the efficiency at high temperature. These kind of concentrating collectors increases the efficiency at high temperature, and there will be less, as we know, is quite normal that if the the temperature is less, then automatically the efficiency also decreases. And these concentrating collectors used for high temperature applications such as steam production for electricity. Wherever we use water for the generation of electricity in mainly thermal power systems or in solar power electrical generation systems, in that systems we use water to produce steam. So at that applications, wherever the water is used to produce steam, in that applications, a high temperature applications, normally water is get heated for high temperature and steam is produced. In that kind of systems, we use concentrating collectors. It is the best use at that kind of situations. Then best suited for climates that have abundance of clear sky days. These kind of concentrating collectors will be very much efficient and suited where the clearance of sky is good, and wherever the normally these kind of things we can see in the clear skies, that is there will be no obstruction of clouds repeatedly, and normally these kind of things will be quite normal in the places where rainfall is less, just like the our areas where rainfall is less. In that kind of places, we use concentrating collectors. As we told, there are two types of concentrating collectors based upon the position of mechanical equipments. There are two kinds of things, concentrating collectors. They are stationary type of concentrating collectors and tracking type of concentrating collectors. So what are the things we can observe in stationary type of concentrating collectors? Are these are operated in stationary mode. That is, there will be no movement of any mechanical equipments. So that's why it's called as, first of all, it's called as stationary equipments. So automatically there will be no movement of things. So operated in a stationary mode. Then uses compound parabolic reflectors and flat reflectors for direct solar energy to an accompanying absorber, or to operate through a wide accepting angle. Wide accepting angle is the very much important thing here. So what it means, the wide accepting angle for these reflectors eliminates the need for an sun tracker. The main purpose of using wide accepting angle is to eliminate the need for sun tracking. Just like have an example of sunflower, right? A sunflower rotates or changes its position according to the falling of sunrises. As it moves from east to west, at the morning time, all the sunflowers shows their face towards east and tracks the same thing compared to as it sun passes, and the solar, these kind of sunflowers flower is also changes its directions. This is the best example of tracking concentrating collector. As I have given the sunflower example, these are the best example for tracking concentrating collectors. But what happens in stationary concentrating collectors? The collectors, whatever the parabolic collectors or mainly parabolic collectors, these collectors will be having wide accepting angle because there will be no movement of mechanical things, mechanical applications. So in order to get the maximum solar radiations, we use wide accepting angle, providing parabolic things. That's why the absorption of solar energy is also very much important here. The next thing is tracking concentrating collectors. Here it includes heliostats or tracking mirrors. There will be a tracking mirror. Just I have given the example of sunflower. These kind of things are also made to track the solar directions, solar sun directions. So that's why it's normally made up of heliostats, and these are tracking mirrors that reflect the solar energy onto a fixed point. Whatever the amount of solar energy that falling onto the mirrors, the tracking mirrors, they made into fall on a fixed point. The absorbed solar radiations are made into fall on a fixed point. That's why it's a tracking concentrating collectors. And the next thing is, what are the different configurations that we can see in the collector configuration? What are the different specifications that a collector should have? That is, if it is a flat plate collector, it's a liquid flat plate or air flat plate. So normally these kind of flat plate collectors will be of liquid flat plate collectors or air flat plate collectors. So in liquid flat plate collectors, what happens? Liquid blazed collectors are sunlight to heat a liquid that is circulating in a solar loop. In liquid flat plate collectors, the collectors uses sunlight to heat a liquid that is circulating in a solar loop. But as in air flat plate collectors, what happens? These are used primarily for solar space heating, and the absorber plates in air collectors can be metal sheets, layers of screen, or non-metallic materials. So there are many different ways that a solar energy can be applied, but there are also many different methods for collecting the solar energy from the incident radiations. That's why some of the more popular types of solar collectors we are using. So in that type, the main thing are flat plate collectors, in that liquid flat plate collectors and air flat plate collectors. The next thing is The most common air and liquid based solar thermal collectors are, so that is the quite commonly used configurations in flat plate collectors and liquid type and air plate are glazed flat plate solar thermal collectors, unglazed flat plate solar thermal collectors, unglazed perforated flat plate solar thermal collectors, backpass flat plate solar thermal collectors, batch plate solar thermal collectors, solar cookers, then evacuated. Normally evacuated means vacuum tubes. Evacuation means there will be absence of air. The absence of air is called as vacuum. So the evacuated flat plate solar thermal collectors also there. Concentrating type of flat plate collectors also there. Flat plate collectors with flat reflectors. Concentrating collectors means these kind of collectors will be having flat reflectors. That's why it's called as concentrating collectors. So till now there are about 8 to 9 commonly used configurations are there in solar collectors, flat plate collectors. Let's see one by one. What is meant by glazed, unglazed, perforated, backpass, batch flat, solar, evacuated, concentrating. We can see in detail one by one. See here in that first thing is glazed flat plate collectors. These are in what happens in glazed flat plate collectors. These are commonly available as liquid or air-based collectors. So in glazed flat plate collectors, the collectors are very common and are available as liquid-based and air-based collectors. Liquid or air is used here as the medium. So these kind of things are in glass plate collectors. These collectors are better suited for moderate temperature. That is, when if the application is for moderate temperature, that is about 32 degrees Celsius, we can use glazed flat plate collectors. And during the winter months, mainly these kind of things, these kind of applications, solar collectors are used in the winter months, and the liquid based collectors are most commonly used for the heating of domestic and commercial hot waters. That is, wherever we use hot waters for domestic, commercial and buildings, indoor swimming pools, in this moderate temperature, that is about 32 to 70 degree kind of situations, at the in between 32 to 70 degree we can use, if we want to use, then at that kind of situations we use glass flat plate collectors. This is the just a representation. This is most commonly you people are observed in our rooftops, solar heaters, solar water heaters. You can see these kind of flat plate, glazed flat plate collectors. In unglazed flat plate collectors, how it differs? These are suited for low temperature application, that is below 30 degrees Celsius. The glazed flat plate collectors are normally using for 30 to 70 degrees Celsius, but in unglazed flat plate collectors, these are the best suited for temperature of below 30 degrees Celsius. And these are made of black plastic which can withstand ultraviolet rays. These unglazed flat plates will be having a black plastic. Black plastic will be used as a absorbing thing and which can withstand the ultraviolet rays. The sunrise contain different kind of rays, microwaves, ultraviolet rays, radio waves, infrared rays, like that. These kind of things withstand the ultraviolet rays. Then since no glazing is provided, it can absorb more heat. If glazing is there, it can absorb the heat instead of, so here in unglazing thing, there is no absorber, so it can absorb the more heat. The insulation is less here, that's why it absorbs the more heat. But losses are also more because of these things, that is because of there is no provision of absorber and there is no and with the presence of black plastic, the losses are also more here. That because of the high absorption, there is a high amount of heat transfer. Because of that, the losses is also more, and they transfer heat so well to air so that they can even capture heat from the air even at night. There is a heat content at the air molecules also. Because of unglazed nature, the amount of air that passing through these unglazed flat plate collectors, these absorber black plastic kind of absorbers even absorb the amount of heat that air molecule contains. So these are even good at night also, and used for heating of outdoor pools, fish farming, preheating water for car washes, etc. That is wherever we use less than 30 degrees Celsius of waters. That is fish farming, preheating water, and outdoor pools. In these kind of situations, we use less amount of low temperature waters. That is less than 30 degrees Celsius. So in these kind of situations, we use unglazed flatbed collectors. See here, these are the different unglazed flatbed collectors. There is no glazing over the plate collectors. You can observe here. There is no glazing. Only flat. It's flat thing is there. There is no glazing. Because of no glazing, even at night also, or even at morning time also, in solar warning, even at normally morning time, there is solar radiation will be there. You can directly exchanges the heat transfer. But during night time also, at summer time, it's the best example at summer time. The amount of air that passing over these plate collectors, a small amount of heat content will be on the air molecules also. These air molecules, small air heat molecules, transfer the heat exchange. The next thing is unglazed perforated plate collectors. So what is meant by this unglazed perforated plate collectors? Unglazed perforated plate collectors. These are industrial grade siding or cladding having perforated small holes at pitch of 2.5 centimeters and mainly used for heating of buildings. That is air conditioners. AC we can say AC, no, air conditioners, but normally quite in our country we use air conditioner for cooling purpose. But in the countries where European countries, we used to moderate the heat at our buildings also. That is, we have to maintain the temperature. There the situation are very bad that the temperature falls below -degree also. For at that kind of situations, we used to heat the building. So at that conditions, we can use unglazed perforated flatbed collectors in order to heat the buildings. Air is passed through the collectors before it is drawn into the building to provide preheated fresh ventilations. That is, a fresh air will be passing through the collectors before drawing into the building. Preheated fresh air ventilation and highly efficient and cost-effective solution. Here, the next thing is backpass solar collectors. This is the backpass solar collector where the amount of large solar absorber is used to heat air. Air is used as a collecting medium here. So the solar absorber is used as heat air, and collectors that are coated with the glaze can also be used to heat air for space heating. In order to provide at the applications of space heating, we use the collector such that a glaze can also used to heat the air. A glaze is used to heat the air. So you can see here. So you can see here in the backpass collector, a structure is made such that air is allowed to pass through the absorbing materials, and a solar absorber is used to heat air. Mainly in the flat plate air collectors, the air is used for transferring the heat. So in air flat plate collectors, whenever the amount of heat that exchanges with the help of air, we here in this application we use a solar absorber to heat that same air, and collectors that are coated with the glaze. A glaze is using air. So in this glaze, collectors that normally these kind of glaze will be using and used to heat the air for space heating. There is a design in simple and they often weigh less than the liquid based collectors because they don't have pressurized piping. Here in this kind of situation, there will be no pressurized piping, so that a simple and weight is less than compared to the liquid based collectors. And in air-based collectors, don't have any freezing or boiling problems. The best application of this kind of situation application is that in the air-based collectors is that these will be don't having any freezing or boiling problems. And in these systems, a large solar absorber is used to heat the air. This is the large solar absorber, so it is used as a absorbing thing. And the next thing is batch flat plate solar thermal collectors. Batch flat plate solar thermal collectors. These are primarily used for residential water heating. These kind of flat plate solar thermal heaters are normally quite used for solar water heating it for our residential purpose, for our home appliances. And earlier in the previous slides, I have shown that black painted water tanks exposed to sun were used. So in modern batch collectors having a glazing to concentrate solar energy on tank surface. A tank will be provided. For that tank, we the which normally those kind of tanks will be having waters. So we have to heat those kind of those waters. So for that purpose, we use batch flat plate collectors. The storage tank and the solar absorber act as a single unit. That is, whatever the storage tank is there, and that storage tank and solar absorber acts as a single unit, and there is no need for other components. Only solar thermal collector and a storage tank is enough. There is no need of another components. So one thing what you people need to remember is this is the best suitable for residential purposes. These kind of solar thermal collectors are best suited for residential water heaters, and there is no much equipments for the heating of solar heating of water. The only requirement is a flat plate thermal collector and a storage tank. A storage tank and a solar tank are the single unit, so no much components are required. Okay. In the evacuated tube collectors, sorry, here the flat plate collectors. These are the flat plate collector with flat reflectors. The flat plate collector with the flat reflectors. See here, these are the flat reflectors. Additional reflector increases the solar yield on the collector and the overall performance of the collector. If some additional reflectors are added into the system, these kind of additional reflectors increases the total solar yield on the collectors. That is about 44% in winter and 15% in summer. These kind of additional equipments provide the total solar yields, and these increases the solar heat exchange in 44% in winter and 54% in the summer season, which is consistent with more hot water demand in winter. These kind of flat plate collectors are more demanded in the winter systems. A variation of flat plate collectors with a simple reflector can markedly increase the amount of direction radiation reaching the collector. This increases the amount of heat radiation falling to high, increase the total efficiency, increases the direction of reaching the amount of direct radiation reaching the collectors, and this is in fact a concentrate because large than the absorber plate. These are the plane reflectors. This is the flat plate collectors. Whatever the amount of solar radiation falling on here is directly absorbed to the single points. These kind of plane reflectors are used to increase the efficiency of solar radiation falling into tube collectors. After flat plate collectors, the next thing is evacuated tube collectors. See here, these are the evacuated tube collectors. This is a typical thing. This is the schematic thing. The conventional and simple flat plate collectors are developed for use in sunny and warm climatic conditions. These kind of flat plate evacuated flat tube collectors are normally used in sunny and warm climatic conditions. However, the benefits are greatly reduced when conditions becomes unfavorable during cold, cloudy and windy days. Whenever the atmospheric conditions are decreased, when gets bad, that is cold, cloudy and windy seasons. So these are best suited at these kind of situations. And we evacuated tube collectors will operate in a different manner, which makes us suitable for adverse weather conditions. The adverse weather conditions, as I told, no, cloudy conditions, windy seasons, and cold conditions. These are the adverse weather conditions. In such conditions, these kind of evacuated tubes are best suited. And for high temperatures, that is about 75 to 180 degrees Celsius. That is 75 to 180 degrees Celsius. That is high temperatures. They're more appropriate for cooling applications and for commercial and industrial applications also. So normally where this kind of evacuated tube collectors we use are highly efficient for cooling applications and commercial and industrial applications. That is wherever the thermal losses we need to minimize. In that less thermal losses, we use evacuated tube collectors. See here, these are the different pictorial representation of evacuated tube collectors where heat in space is provided. Through that, cold water is inlet, hot water is outlet. We need to transfer the heat, solar radiation heat, through this medium to increase the heat, to change the water from cold water to high water. So here the heat exchanger are copper manifold. This is the copper manifold which exchanges the heat from water, low cold water to hot water. The water is inletted here, and through this here, these are the tubes, heat pipe. So from these individual evacuated tubes, our fluid is passing, above which solar radiation is falling. After circulating for n number of absorber plates and heat pipe, finally heat transfer is changed and hot water we get. This is the picture represent. This is the actual available at market. That photograph. So this is the scientific diagram, schematic evacuated tube solar collectors, schematic representation. This is the complete one set of diagram. This is the individual single, this kind of single tube-like structures. That diagram. Solar radiation is falling on the tube, and water is inletted here. Through that water through the tube-like structures, water is flowing here, and a bend-like structure collects the heat. These pipe collects the heat from the solar radiation, converts this cold water into hot water. This is enough for today. We will discuss the remaining things in the next session.